Yes. Now let us do the lab experiment 1. So it's a basic gates. So all the gates in a single. So as you know, the input will be A, B. The outputs will be like a different outputs, because in a single same variable output P, I cannot get the output of AND gate, NAND gate, OR gate, all those things. So for each and every gate, we need a separate output variable. So you have to decide. So I'll say the P gate is nothing but for AND gate. Then for Q is for OR gate. Then R is for NOT. It is left to us. This is NOT gate. Then this is for NAND. Then this is for NOR. Then this is for XOR. Then this will be for XNOR. Simple. Just I'll say the output of this one each and every variable like this. So how we will make a truth table actually? The truth table will become like this. Simple. One single truth table we can form better. Like for example, A, then B. Both are the inputs, right? Then we'll get the output like P, Q, R, S, T, U, V. Yes, these are the outputs actually. So now how we can make it? Say example 0, 0. Input is 0, 0. What will be P? The P is nothing but an AND gate. So output will be 0. The Q is what? OR gate. So output is 0. Then R is NOT. So NOT of which? Either A or B you can choose. So I'll say A. So 1. What about next is S? S is for NAND. NAND means 1. Next, because NOT of AND. Next R means 1 only. 1. Next, what about U is XOR. XOR means 0 only. XNOR means 1. See, like this you can frame your truth table like this. So like this you frame it, complete truth table. Next I will go for the program, Verilog code. I will write a Verilog code now for this. Verilog code for basic gates. Okay, let us start first. First is what? Module. Module followed by what? Module name. Which is our module name now? The module name is here. I written, see, what is it? Basic gate. So my module name is basic gate. Basic underscore gate you give. Don't write basic space gate, because as you know the rules. Initially I said some rules, right? I hope you remember. So to write the module name should not have the space between two words. So that is what underscore basic is. Now followed by what? List of input comma output. List of input comma output means our inputs are what? A comma B. Outputs are here what? P, Q, R. So I will write caps here. So better I will write that only. P, Q, R, S, T, U, V. These all are outputs. As I said earlier, it is not mandatory you have to give in this order only. You can change any order. But so we recommend to write input comma output, A comma B comma in the sequence order. Else you won't get any problem. Now what is next procedure? Because system still doesn't know which parameter or which variable is input or output. So further what I should do? First let me segregate the inputs. So which is the input now? Input is A comma B. Then output. Which are the output now? P comma Q comma R comma S comma T comma U comma B. See here one more thing I'll say. Even you can write like this also. See here input A semicolon, input B semicolon, output P semicolon, output Q semicolon. Like this also you can write. You can separate individual also you can write, or you can write like this also. So better which is this you can use in that way. So better this will be better I felt. Output. Next what I will do? Next let us go for assign. See here assign. Yes, now you think assign. Let us write first output is what? P. So P is equal to what? AND gate A and B, then semicolon, then enter. Next again you write assign. Q is equal to, next gate actually, Q is equal to what? A or B. A or B. OR gate. Next, assign PQ R, no? Yes, PQ R. Next is R, output is R. R is for what? NOT gate. So I'll say NOT of A or B. It is left to us. Next, assign PQ R S. S is equal to, what is S? NAND gate. So NAND gate is how we'll write? NOT of A and B. You have to write like this. Next, assign S after S T. T is equal to, what is T? NOR gate. This A or B, then semicolon. Next, assign T after T U. U is equal to not of XOR, right? Though A XOR B. Next, assign B is equal to not of A XOR B. See, everything is over, then you can close module, end module. See, now you may think we written multiple assign statements here for each and every output variable. You can see. Now we can, this one, this only this portion, which portion? Only this portion I can replace now actually in a simple
Sir,
way.
for output of R, sir.
Nice. Output of OR gate. Yes.
Sir, for output of R, we are giving A not B now, sir. Then we are
Output of OR gate. Output of OR gate is okay. As you are saying, like always, not you are saying NOR or OR.
sir not for only not, sir.
Not is this. See?
Is the
You have to
urinary
not of-
expression.
You have to say this expression. It's a unary operator actually. Tilt operators, you know, that you have to use. That is for not gate. You may think.
And for B, sir, B input.
Okay, for B input, what you do say, because NOT gate has only one input, right? Only one input.
Yes.
How, yes. So how we can write in the sense? So instead of this, say example, I'll write as here R. Okay, if you want to write as not B, you have to write. Simple.
Okay.
Not B. Like this you can write because NOT gate has only single input.
One. Yes, sir.
Okay. Yeah. Okay. Now you see here I specified assign statement for each and every output variable, right? Instead of this, what I will do, I will modify this here in simple way. The only this statement which I highlighted right here. How will I write the sense? See, assign P is equal to A and B and B. Instead of putting semicolon, I will put comma actually here. You see. If I do like this, I no need to write once again assign statement. Straight away I can go for Q is equal to A or B. I hope you understood now. Not semicolon. Don't put semicolon. If you put the semicolon, the statement is terminated. So use comma. 2. Next, R is equal to not of A, comma. S is equal to not of A, B, comma. Next is after S, T is equal to not of A or B, comma. Very, very important after T, U. Next is U is equal to A XOR B, sir, comma. Next, B is equal to not of A XOR B. Now you see after that, is there any statement? No statement. So now use the semicolon. So terminated. Now we can see comma is so only single assign is sufficient if you are having multiple output parameter. But here one more thing very, very important. You see the input A and input B will accept only one bit. See, that is very important. If the input is 1 bit, the output also will be 1 bit, 1 bit binary digit. So A is 1 bit binary, B also will be 1 bit binary, when you perform the operation, the result also will be a 1-bit binary only. So at these cases only I can use this comma. If we're having more than that, we can't use the comma. We need to go separately assign. So that will go come in later. So finally, what you have to do here, you have to write as here. Finally, I should write as end the module. There is no semicolon. You can see this is what the changes we have to make. Either both are correct. I'm not saying this you are correct or only this. Either this or this you can write. Now this will be a complete program for the first experiment of your HDL lab, Verilog HDL lab. First experiment, Verilog code for basic gates in Verilog. So what you do? So in the next class, so how to execute this in the software actually, so that I will show for you. How to execute in a software. So as I said earlier, I will upload. Still, I am not uploaded. Let me upload. Okay, let me upload. Then you can download that. Or if anybody else, you can try in the net. Even the student version also is there. You can download and you can install also. Xilinx 14.5 in net it is available actually. It is free only. Even you can download, you can install.